Hey guys, okay, so y'all are gonna have to bear with me here because I just figured out that I cannot write on my screen with Google Slides. So we're gonna try this out. Today we're gonna be talking about the number theory and integers. And integers are just gonna be like the natural numbers, like the counting numbers or positive integers, like 1, 2, 3, 4, and so on. And they're also going to be the negative numbers, like the -1, -2, -3, and all the way to infinity. And then the number 0, which is going to be neutral. And then for number theory, we're going to be talking about the study and properties of all the whole numbers and the way they interact with each other. And now we're going to be talking about things like divisors, factors, multiples, the way the composite numbers are written as prime numbers. And we're going to test the natural numbers for divisibility by numbers like 2, 3, 4, and so on. And then we're also going to be talking about least common multiples. And they're even going to do a little fun thing like a magic number square. Now, I'm going to have to be switching back and forth between my presentation so I can try to do this math with you guys. I really wanted to write on my screen for this, but instead I'm just going to have to talk you through it and possibly use some paper. Okay, so first we're going to get started with this chart right here. And we're going to be testing out numbers to see if they are divisible by 2. Well, a good way to know if a number is divisible by 2 is if it is an even number. So we can see that 684 is an even number. And then we can just look across the top and see what all these other even numbers are. And then there's one odd number. So that number is not going to work. And now for 3, it's going to be a little bit more interesting. For 3, what we're going to do is we're going to total together all the sum of, let me see if I can at least use a pointer. What do we got here? Okay, here we go. We're going to calculate the total of the numbers here. And when we add together 6, 8, and 4, that is like, let's see, 8 and 4 is 12, plus 6 is 18. And we can either know that 18 is divisible by 3, or we can go ahead and break that down a little bit further and add 1 and 8 together. And that's going to give us 9. And 9 is definitely divisible by 3. And now let's move on to 2064. 2064 is, let's add up those digits together. We're going to say 2 plus 6 is 8, plus 4 is 12. So we can see that this number is also going to be divisible by 3. And then 5 plus 1 is 6, and then another plus 5 plus 1 is 6. That's going to be 12, so that's also going to be divisible by 3. And then let's keep going, and we're going to say 6 plus 4 is 10, plus 4 is 14, plus 4, plus 4 is 18, plus 9 is going to be 27, and then we know that 27 is divisible by 3, or 2 plus 7 is 9, so that's also going to work. And now we're going to get into some bigger numbers. So this is going, let me turn my phone. We're going to add together 2 plus 6, and then we're going to add plus 7, plus 6, plus 7, plus 4, and that's going to give us 32. And it may seem like 32 might be divisible by 3, but if you add 3 and 2 together, that gives us 5, and that's just not going to work. And then we're going to go to this bigger number, and we're going to say 5 plus 2 is 7, plus 5. And we're going to skip the zeros, plus 5 plus 2 plus 8, and that'll give us 27, or 2 plus 7 is 9. So that is going to work. And then now to do 4. If it's divisible by 2, it might be divisible by 4, but we have to be able to get 2 2's out of it, like 2 times 2. So let's say 6 plus 8 plus 4 is 18, and 18 is not divisible by 4, but we can look at the last integer and the last 2 integers and know that they are divisible by 4. 4 is divisible by 4. 8 is also divisible by 4. So if the last 2 numbers are divisible by 4, it is going to be divisible by 4. Even if the total isn't going to be divisible by 4, it's not the exact same as 3 and 2. I just did that in the beginning to show you that you might try to use that same tactic and it seems like it'll be wrong, but that's just not the right approach for 4. And then if you can look on here, I should have done this with 3, but if you look together the factors of 2 and 4, if it has 4 and 2 and it's divisible by both of those, it's going to also be divisible by 8. So we can look again at the next number and know that 4 is divisible by 4 and also 64. So we can go ahead and put the smiley face there. And then on 5151, well, 51 is not going to be divisible by 4. So we're going to go ahead and put our little X there. Oh, I forgot. Let's put our 8 because we know that 2 and 4 are factors. So let's do that. And then let's keep going. And it also, if it's not divisible by 2 or 4, then we can safely say that none of the other even numbers are going to work. Like we're just not going to, we're not even going to waste our time going, because if it can't be broken down to 4 or 2, then it cannot possibly be 6, 8, or 10. Okay, let's keep going. 90. Let's see. We could. I think that's also going to be divisible by 4. Oh, yeah, I meant to tell you guys that it's the same thing. The same property applies to 2 and 3. If it breaks down to factors of 2 and 3, then it also is divisible by 6, because 6, if you prime factor it out, we'll get into that later, that is going to be 2 and 3 they break down into 6. So let's keep going. We're not going to have 4 here, and we are going to have 4 here because 40 is obviously divisible by 4, and also 28. Okay, now for 5, that's going to be a little bit easier. If it ends in 0 or 5, it is going to be divisible by 5. So we can easily tell that those other numbers are not, but the 2 ending in 0 will be. Okay, now for 7. 7 is kind of tricky and a lot of fun. But what I like to do in my mind, I like to take my last number, which is going to be in my units position here, and I'm going to double it. I'm going to say 8, and then I'm going to take 68, which left, and I'm going to subtract 8 from it. And that's going to give me 60. 60 is not divisible by 7, so I'm going to keep going. I'm going to take my units place. I'm going to say 8. I'm going to say 206 minus 8 is going to give me 198. And then I'm going to go ahead and take that units digit again in the 8, and I'm going to double it, and I'm going to say 19 minus 16 is 3, and that's also not going to be divisible by 7. But then if I take the 1 and I double it, I'm going to say 5103. 5103. And then we're going to go ahead and take that 3 off there. And we're going to say 510 minus 6, which is going to give us 504. We're going to say 50 minus 8. And that's going to give us 42. And 42 is divisible by 7. Okay, let's keep going. Since we have a 0 in the last unit, we're going to just automatically cross that out. So we're going to say 6,444. We're going to say minus 18. That's going to give us 6,426. And then we're going to take that 6 off of there. So we're going to have 642. And we're going to double the 6 and subtract it. So 642 minus 12 is going to give us 630. And then we're going to cancel out that 0. And then 6 minus 6 is 0. And that is 0 is divisible by 7. So this will actually work. And then we're going to keep going. And we're going to say 26,700. Wait, did I not say that number correctly? 267,674. But then we're going to take the 4 off, and we're going to double that and subtract it. 26,759. We're going to take the 9 off. 26,759. I feel like I made a mistake here. Let's start all over with that one. 267. 67. These numbers are so confusing. And then we're going to subtract 8. And then we're going to take off our, yeah, that's right, 2675. And we're going to subtract 18 from that. Then we're going to take off our 7 because that's going to leave us with 2,657. So it would be 265 minus 14. Then we're going to have 25 minus 2 is 23. And 23 is not divisible by 7. And then we're going to go with this really long number, and we're just going to take the 8 off the end. So minus 16. And that's going to give us 5,025,036. We're going to take that 36 off of there. So 5,022. I'm not even going to say the numbers places because I am not there right now. Okay. 5 minus. Okay. So then we're going to say 5,025,000, and but then it's going to turn into 50,253 minus 12. And then we're going to say 5,024 minus 2, and then 502 minus 4, and then we're going to take 49 minus 16, and that's going to give us 33. And this is also not going to be divisible by 7. Let me move myself over here. And then now we have this other chart right here. We can see that this one is not going to be divisible by 8 because it's not divisible by both 2 and 4. All right, let's move on to 9. 9 is also going to be kind of funny. It's similar to 3, but you have to be able to get 3 3s out of it or be divisible by 9. So when we know that the first one is going to be totals to 18. And if 18 is divisible by 9, it's divisible by 9 twice. Or you could add the digits together. 1 plus 8 is 9. So this is going to work. I'm not sure why that one popped up there, but that one's not divisible by 9. And then we're going to get to 10 plus 2. 12 is not going to be divisible by 9. And then we have, again, 12 isn't divisible by 9. And you can look here too and know that 90 is divisible by 9. But let's go ahead and add these others together. It's going to be 12, 18 plus 9 is 27. That's divisible by 9 3 times. And then this last one, we add them all up together, and that is not divisible by 9. And for 10, it's going to be super easy. If it ends in 0, it is divisible by 10. If it doesn't end in 0, it is not a multiple of 10. Okay, for 11, it's really fun and kind of tricky. But what you're going to do is you're going to take, I might use my paper for this one. I dropped my pen earlier. Let me grab it. Okay. For 11, let me grab some paper really quickly. You're going to take the first number and then subtract the second number and add the next number and so on, going counter. So what it's going to look like is going to be like this. We're going to say plus 6 minus 8 plus 4. And that's going to give us 10 minus 8, which is 2. And 2 is not going to be divisible by 11. And then let's go ahead and keep going. I don't know if you guys can see this or not, but let me try it again. We're going to say plus 2 minus 0 plus 6 minus 4. And we can group our like terms. So we're going to say minus 4. This is going to be 8 minus 4 equals 4. So this is also not going to be divisible by 11. And then we have 5 plus 5 minus 1 plus 0 minus 5 plus 1. So we have minus 6 and we have plus 6 is going to be 0. And 0 is divisible by 11. So let's keep going. I would grab the pen that didn't have ink. Okay, we have plus 6 minus 4 plus 4 minus 4 plus 9 minus 0. Let's group our like terms up here. So we have 6 plus 4 is 10 plus 9 is 19. Then we have 4 minus 8. So 19 minus 8 is 11. And 11 is definitely divisible by 11. Okay, let me move me over here. Whoa, that was fast. Okay, let me grab another piece of paper because I'm running out of room here. Okay, and My little daughter was drawing earlier. That's so sweet. Okay, let's try this. Plus 2 minus 6 plus 7 minus 6 plus 7 minus 4 plus 0. So let's group our like terms. 2 plus 7 is 9 plus 7 is 16. And then we're going to subtract 12. What is 12 plus 6? What is 12 plus 4? 16? Yeah. 16 minus 16 is also 0. So 0 again is divisible by 11. Let's keep going. Plus 5 minus 0 plus 2. Oops, minus 5 plus 0 minus 5 plus 2 minus 8. Here we go. Let me rewrite these because my pen quit working on me. Minus 5. So let's again group our like terms. I don't know if you can see this, guys. We're going to say 5 plus 2 is 7, plus 0 is 7, plus 2 is 9, minus 5 minus 10 minus 18. So 9 minus 18 is going to give us negative 17, and that is not going to be divisible by 11. Okay, I may have to go and switch some apps so I can write on my screen this time because the writing on the paper just isn't cutting it for me. And Google Slides is not going to let me write on the slide. So let's keep going to this next problem. Now that we've kind of got a handle on some tricks on divisibility, let's see if we can try to learn a new trick, and it's called casting out the nines. And this is kind of a way to check our math whenever we're doing like addition or subtraction, even multiplication. What we're going to do is we're going to look at a problem like this right here. We're going to look at this, and then this is the total that we got whenever we just hurried up and we added them together. Now, okay, I'm going to try to switch my app just because I want to be able to write on my screen for you guys. So let's see if we can do this. So I'm going to try to present it this way. I'm really sorry to be switching back and forth, but just please bear with me. I am the type of person that TVs will static and radios will shut off and streetlights go out. I really mess with technology a lot. So let's see if I can... Okay, that's not going to work either. Let's go back. Okay, we'll just roll with it, and I'll just keep using my paper to try to explain. Okay, so what we're going to do, had these great animations, and I was like, oh, I'm going to write on my screen, you know, with my expensive computer that I wasted all this money on. Okay, let's use my paper again. So casting out the nines is pretty much what we were doing earlier whenever we were adding together to try to see if it was divisible by a number. So what we're going to do is I'm going to go ahead and write down this problem on the paper so you guys can see here. And then I'm going to go back through and we're going to check our math really quick. I'm not even writing the correct numbers down. That might help. Okay, so whenever you're adding numbers here, whenever you cast out nines, you just basically, we're going to total these digits together. And so we're going to look at anything that has a 9. And like we can already see here that this 9, we can cast that out automatically because we're not going to add 9 twice. What we're trying to do is reduce the number to the smallest component it can be. And so for this very first number right here, we're going to add 4 plus 6 is 10 plus 1 is 11. And that's going to give us 11. And then we're going to keep reducing that to either 2. But let me give you a trick about this too. 11 minus 9 is 2. 1 plus 1 is 2. This is always going to be your remainder to be reduce, like we do recycle, reduce, reuse, recycle. It's the same thing with math. We're going to protect our environment and keep our brains smart. So here we go. Now, like I said before, we're going to cast this 9 completely out because it doesn't even matter. We're not going to add it twice. So we're going to have 7 plus 4 is also 11. So we're going to have 2 here. And then 6 plus 4 is 10 plus 18. Hold on, that's a 9. So we don't need that 9 because 1 plus 8 is 9. So we're casting that out. Get out of here. And then this is going to be 4. Now, I'm running out of ink in my pen. Okay. It looks full to me. Look at that. Okay, so now we're gonna cast this 9 out because we don't need to add it again. And we can see that 7 plus 2 is also 9. And that's gonna leave us with a remainder of 2. Well, we have 2 plus 2 plus 4. That's gonna give us 8. And then this is gonna have a remainder of 2. So 8 and 2 do not match. So we've made a miscalculation somewhere along the way. And we're gonna need to go back and fix that. And now the same concept goes, let's try it again. We're going to do a couple more problems just to see if we can really figure this out and if it really does work for us. So we're going to look at this one, 78,362 minus 3,674. And the total that we first originally got was going to be 74,678. So let's go through here and see if we can find any 9s to cast out. Well, automatically I see that 7 and 2 and 3 and 6, those total 9. So I'm just going to put 8 for my number here at the top. Just across here, I'm casting out those 9s, getting rid of them. And then I'm going to take 6 and 3. That is also going to be a 9 cast out. And 7 and 4 is 11, or 1 plus 1 and 2. And then our total down here was going to be 74, 6, 7, 8. Okay, so we have 10 and 14, that's 24, plus 8 is going to be 32. 32 is 5, and then we have 8 plus 2 is 10, or 1, and 5, and those also don't match. So again, we're going to need to go back and redo our calculation because somewhere along the way, we made a mistake. And casting out 9s is not a trick to see if something is divisible or if your math, is exactly right. But it is a way to check your math to see if you've made a mistake without actually going all the way back through each one and redoing it. Now, let's try to add some more numbers to see if we can cast out these 9s. Maybe we can do it without me writing it on the paper. I'm so sorry that I can't interact with my screen. My computer's being rebuilt, and I'm using my laptop right now. And so just please bear with me. So we're going to go through here. And, out of habit, I keep trying to. I just told you I couldn't write on my screen. Okay, let's go through here and cast out some 9s. Okay, so 8 plus 5 plus 5 is going to be 18, and 18 is 9, so we can cast that out completely. It's gone. And then 8 plus 8 plus 8 is 24, plus 6 is 30, and so we're going to have 3 plus 0 is 3, so we're going to have 3 there. Let me write this down so I do not forget, because maybe I should have written all this down for you guys. Okay, 2 plus 5 is 7. 2 plus 5 is 7. So we're 7 plus 7 is 14. 1 plus 4 is 5, or 14 minus 9. We're going to cast out that 9. Is going to leave us a remainder of 5. That's a cool trick about this. No matter what you do, it's always going to be either the sum of the two numbers that you're going to reduce, or that number subtracted 9 is always going to be your same answer. So I guess you're double checking your math here. And then we're going to cast that other 9 and 6,029 completely out. So 6 plus 2 is going to be 8. And then if we total up those numbers, they should total 11 plus 5 is 16. Our remainder should be 7 if our math is correct. So let's go ahead and get rid of that 9 that we see there. And we're going to say 2 plus 3 is 5, plus 2 is 7, plus 8 is 15. So 1 plus 5 is 6. So 6 and 7, again, do not match. We've made a mistake somewhere along the way. And if I could interact with my screen, I would totally go back and rewrite all this so we can figure out exactly where we made the mistake and went wrong. But let's do something a little trickier. We're going to do some math. Multiplication. We're doing math the whole time. Okay, so 13 is going to be 1 plus 3 is 4. And then we're going to multiply that by 8. And that's going to give us 32. Or it should give us a remainder of 5. So now we can cast out these two 9s at the bottom automatically. And then that leaves us with 6. So again, we have not made a correct calculation here, and we're going to have to go back and do it again. So if we were to go back and do this again, we would see that in one of these digits we have made a mistake, and it would have to be in the 40s place, or the 2 digit. Like one of those digits is going to have to be completely left, or it could even be one of the 9s that we immediately cast out. Like we have made a mistake on one of those digits. They need to be 1 off, because our remainder should either be 7 or we have made a mistake completely, because our quotient, or not 7, it should be 5. I thought I'd made a mistake there. Okay, now let's go ahead and keep going. And we are going to look at some bars, some little number bars. And these are going to be really fun. Like whenever you're in person, these are actually little cubes that you can connect to each other. And you can make, they're called trains. You can make number rods, and you can break them. You can use them to break down to find greatest common factors. And it's a really fun tool to use. So let's go ahead and see if we can go through some of this and see which bars can go into the 9 bar. And that's actually a 3 bar that I meant to add an animation on. But we know that 9 is divisible by 9 and 1. So let's go ahead and fill it in with 1. So we know 1 is going to work. And then we have a 6 bar down here that can also be 6 and 1. So we know that my animations are really adding up. So we know 2 is not going to work in 9 because it's not an even number, and it's going to spill over. So let's go ahead and take the 2's away. That is not going to work. And then 3. We know 9 is divisible by 3. And then it's not going to work with 4 because it didn't work with 2. It doesn't end in 5 and 0, so it's not going to go into 5. It can't be divisible by both 2 and 3, so it can't be 6. And then 7 it has a remainder of 2 that can't fit. And so we know it's going to be either 1, 3, or 9 that goes into the 9 bar. And now for the 6, we saw that it could be either 6 or 1. So let's go ahead and put our 1, and then we know that 6 is divisible by 2 and by 3. So we see that what we have in common for both 6 and 9, our greatest common factor is going to be 3. And what's so cool about those number trains is not only can you see what fits inside of each other, you can actually attach them together. And what we're going to try to do is we're going to go and attach an 8 bar and a 10 bar together. And then basically with the same what we did earlier, I don't think my computer allowed me to do transitions on this one. So what we're going to do is just talk through it. And if we know that 18 is divisible by 6 and by 9. So what we would do is we would fit those bars in to see how many times it would fit. So if 6 and 9 are divisible by, or if 18 is divisible by 6 and by 9, then it must also be divisible by 3, because 3 is part of the prime factorization of 6 and 9. And so we would have 1, and then 18 is even, so it would be also divisible by 2. So we would have 1, 2, 3, 6, 9, and 18. That's what's going to fit into our, it did let me do it. Okay, awesome. Okay, that's great. So we were able to see that they did all fit in there. Oh, that's great. Okay, and now we're going to do something like the least common multiple. And I'm so sad that I can't write all this out because I planned on drawing it all on the screen for you guys. This is just pitiful. Okay, I may try to re-record my video when I get my computer back in a couple of days. It's a long story. I'm not going into it. So we're going to be talking about the least common multiple between 48, 25, and 65. And the least common multiple is going to be what number, whenever you're listing them out, like if you said 25, it would be 25, 50, 75. Okay, what other number, like 48, when do 25, 48, and 65 like link up at the same? What is the lowest number you have to get for them to be the same? This would be the least common multiple that they all share. So what we're going to do is we're going to figure this out by prime factorization. And prime factorization is going to be whenever we take a number that's larger than 1, and we're going to break it down all the way, because every number that's higher than 1 is going to be a product of prime numbers. And so we're going to try to break it down and see what those prime numbers are, because we can use those prime numbers to calculate. Instead of listing out and making a list and going on and on and on, we can just use the prime factorization to piece it together. And I really wish I could draw it on my computer, but I'm going to have to try to explain it with my paper. Maybe I can go ahead and make my screen a little bit larger so you can see me slightly better, and maybe my paper. Here we go. Whoops, let's go back one slide, because we're going to keep practicing to see if we really get this right. And maybe I guess this is as big as it's going to let me be, guys. I don't really know. I'm trying to be bigger here for you. Okay. Maybe you can see this. So what we're going to do is we can see that one of these numbers is even. So the 48 is definitely going to be divisible by 2. And it goes into 48 24 times. Well, that's also even. So we're going to go ahead and break down this even further. And it's going to be 2 and 6. And 6 breaks down into 2 and 3. And these are going to be all the prime numbers that make up the number 48. So the number 48 is made up of 4 2s and 1 3. So we're going to go ahead and write 2 to the 4th power times 3. That's going to be on our chart here. Or we can go ahead and make it a list like this. We're going to say 2 times 2 times 2 times 2 times 3. And then for 25, we can see that it ends in a 5, and 5 is a prime number. So we're going to go ahead and break that down, and it's going to be 5 and 5, and that's actually, both of those are prime numbers. So the prime factorization of 25 is 5 times 5. And even my pen isn't working. Okay, so 65, we're going to say 5. Come on. Okay. There we go. All right. So 5 goes into 65 13 times, and that is all. These are both going to be prime numbers. So what we're going to do here is we're going to go back down to our chart. I'm going to rewrite this really quick so it'll be easier to read. 2 times 2 times 2 times 3, and then we're going to have 5 times 5, and then we're going to have 5 times 13. Now, the way we're going to figure out the least common multiple is we're going to see what matches, and none of these match. So we're going to have, here they have 5, wrong way, 5. So we're going to cancel this out, and we're going to say 2 times 2 times 2 times 2 times 3 times 5 times 13. So this is going to be our least common multiple. So it's going to be 16 times 3, which is 48, times 5, which is 600. Is that right? I probably should get a calculator because my brain is buzzing out. Let's see. 240. Why did I think that? 240 times 13 is going to be 3,120. And that seems like a ridiculously big number, but if you remember, the 5s have to have a 0 or a 5. And whenever you are thinking about the number ending in 8 or 48, chances are you're going to need, a really big number to match up 5s and 8s. So that it does kind of make sense that it would be that big of a number. And now we're going to go ahead and try to find the least common multiple of 40, 12, 44, and 363. So let's go ahead and break down our table. And we can see that many of these are even. So we're going to go ahead, and I'm going to write my chart like this. I'm just going to go ahead and divide all the even numbers by 2, and then I'm just going to leave this one empty. I'm just going to drop this number down because it isn't divisible by 2. So we're just going to leave this one out and pretend like we're not even going to factor that one yet. Okay, so it goes into 12 6 times, 20 times, and 22 times. Well, those are all even numbers and can be broken down even further by 2. So we're going to go ahead and divide. Again, we're going to leave this one out completely because it's not divisible by 2. And we're going to write our 2 over here. And then we're going to bring a 3. So this is a prime number. This is a prime number. This is also a prime number. And then we're going to just keep going. So now we have a 10 and an 11. Oh, that's a prime number. So we're going to circle that. Now we're going to drop our 10 down here. We can factor that even further because that is divisible by 2 and 5. So that's going to give us another 2 and then a 5. And then now we're going to go over here and we're going to try to factor our 363. Well, 3 plus 3 is 9 plus 3 is 12. So if it's not divisible by 2 and then 12 or 1 plus 2 is 3, that is divisible by 3. So let's go ahead and factor that with a 3. So we're going to say 363 divided by 3 is going to be 121. And luckily, I know from years and years of math tables that 121 is going to be 11 times 11. And both of those are going to be prime numbers. So what we're going to do is we're going to take all of our 2's. We're going to have 3 of those. So we're going to say 2 to the 3rd power. And we're going to take our 3's and we're going to say there are 2 of those. And we're going to say to the 3rd power. And then we're going to take our 5's. There's 1 of those. And then we are going to take 11, and there are 3 of those. So you guys, this is going to be a giant number. And I'm not going to calculate it at the moment, but this is how you would figure that out. And this is going to be your giant number. So whenever you multiply all these out, you're going to find your least common multiple of these numbers. So let's try one more. I believe there's one more. Yes, let's try one more before we get into something really tricky and fun. Okay, let's try to find the least common multiple between 250, 28, 44, and 110. Well, something I can see right off the bat, these are going to be even numbers, and so they are going to be divisible by 2. Let's go ahead and factor it with 2. So we have 250 divided by 2 is going to be 125. 28 divided by 2 is going to give us 14. 44 divided by 2 is 22. 110 is going to give us 55, I believe. My numbers are correct. I'm going to stick with it. Okay, so let's circle our 2. And then let's go down here, and we have some even numbers. So we're going to go ahead, and we're going to divide that by 2 again. Not 125 and not 55. But we are going to do 2 and 7 is 14. 2 and 11 is 22. And now let's move on with our 5's because these end in 5, and we learned earlier. So we have 5 goes into 125 25 times and into 55 11 times. There's another one. And then we have 5 and 5 for 25. So we have 2 to the 2nd power, 5 to the 3rd power, 7 to the 1st power, and 11 to the 2nd power. And that again is going to be another giant number that we've used to find our least common multiple between these numbers. Okay, now we're going to do something with the least common multiple and also prime factorization that we learned a few moments ago. And we're going to go ahead and try to look at some gears. And, you know, my grandfather he worked on clocks. And so I grew up around gears and all kinds of things. And I never thought of this concept that if there's a small gear and a large gear, how many times does the smaller gear have to rotate to match the rotation of the larger gear. And not just that, but I mean their points to come exactly, not close, because sometimes it's 1 or 2 teeth off. We're going to see how many times does it have to go for them to touch exactly. And this is a kind of a cool little diagram, because it looks like on this that it's going to be 3 times, but if you look really close, they actually don't come to the exact same spot every third rotation. So we're going to look at something with the teeth. It's going to have 48 teeth and 84 teeth. Let's quit that spinning. It's driving me crazy. Okay. So to find this, we're going to do the prime factorization of both 84 and 48. And so if you start to break that down, it's going to be like 2 times 42 and 2 times 21, which would be 3 and 7. So that's going to be 2 to the second power, 3 to the first power, 7 to the first power. And you're going to put that over on the side. And then you're going to prime factorize 48, which is going to be 2 and 24, 2 and 12, 3 and 4, 2 and 2. So it's going to be 2 to the fourth power times 3. And so what you're going to do is you're going to see what is the largest, the maximum amount you have there. So you're going to have 2 to the fourth power is going to be the largest. And then you're going to have 3 to the first power, because so it matches, and both of them, they both only have 1 3. And then you have a 7. So we're going to multiply that all out, and it's going to give us, it's going to be 16 times 3, which is 48 times 7. But hold on. One of our gears has 48 teeth. So we can, again, like our casting out 9s, we're going to cast that out because it cancels itself out. So a good way to help us figure out how many rotations the 48 teeth wheel has to make, it's not going to replicate 48, 48, and 48. So 48 is itself. So it's going to cast itself out. So what we're left with is 7. So the smaller wheel is going to have to make 7 full rotations for point A and point B to meet back together at the exact same spot. That's pretty cool. And now we're going to look at something magical. And I'm not talking about like David Blaine or Maxwell Blade. I'm talking about math. Okay, let's look at these numbers. So there's not anything significant about these numbers other than the fact that they're in order, right? Well, I don't know if you guys are Sudoku fan of Asian languages, Sudoku puzzles, but anyway, they are sort of like magic squares. And when I'm talking about a magic square, what I mean is you're going to take, since there are 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there are 9. We're going to fit each one of these 9 numbers into a square. But the fun thing is we're only going to use them one time. But the fun part about this is to figure out what our magic number is going to be. We're going to take the sum of all the numbers provided. So we're going to add all these integers together. And we're going to say like -7 plus -6 plus -5 plus -4. So this is going to be -28 plus 1, so -27. And then we know we have 3 boxes in each row in each column. So what we want to find our magic number, we're going to take this sum and we're going to divide it by 3, because whenever we add the 3 boxes up and down, across, and even diagonal, they're going to give us the same magic number. And that's what's magical about it, is it's kind of mind-blowing that if you can arrange these numbers to where each row, column, and diagonally will give us the sum of -9. So my very first start that I would do, and I'm so sorry I wish I would have went ahead and did the animations. If I'd have known I wasn't going to be able to write on my screen, I would have. I'm just going to use my little cursor here, and hopefully you guys have a really good memory. So, and maybe you can write it down on your own paper so you can see if you're a visual learner, you're going to need to see this. What I would do, my very first logical step to take would be to try to balance out this 0 and this 1. And I would just try to put the -7 here. Well, if I have, my total is supposed to be 9, then I'm going to go ahead and go down, and I'm going to fill in a -2 here. So that'll be -7 and -2, and this is all going to total to -9. Well, if this is -7 and this is +1, then this is going to need to be -3. And then, like I said before, the diagonal to fill it in and fit, this would have to be -4 because -2, -3, and -4 add up to be -9. And then if this is -3 and this is 0, then this must be -6. And you know what? Magically, -4, -6, and +1 also total to be -9. And that leaves us left over with -5. And -5 here, -3 here, and -1, because this would be -3, -1, wait, -2, -1, -6, -3, -5, and -1. So I really hope you can take the time to write all that down and figure it out on your own, and maybe try some new numbers and figure out which integers can give you a magic number and make a magic square, and maybe have some fun, when you're waiting for Thanksgiving dinner to be cooked in a couple of weeks. And you guys, that's really all I have for tonight on number theory and integers. And if you guys want, to learn some more, just look on YouTube. There's so many videos out there that you guys could learn so many awesome things with numbers. Math is fun. Thank you so much for hanging out with me tonight and bearing with me through all my technical difficulties. I hope you guys have a wonderful evening. Thank you so much.